Hello students, welcome to this video. This is the fourth and the last video for lesson 8, Solve Systems of Equations Algebraically. In this video, we are going to learn how to extract informations from words, to convert words into systems of equations, and then solve the system of equations. To do so, we are going to solve the exercises for Got 80 questions on page 246. Okay, we have a word problem here. Okay, a problem written in words. We need to convert these words into a system of equations, then solve it. Okay, we can see here the question is: Mr. Thomas cooked 45 hamburgers and hot dogs at a cookout. He cooked twice as many hot dogs as hamburgers. Exercise E: write a system of equations to represent this situation. Okay. Exercise F: solve the system algebraically, then interpret the solution. So what do we need to do is to extract the important information from these words here and then write them as an equation. Okay? We basically need to write two equations, which is called a system of equations, of course. So let's start reading this equation and extracting the basic and the most important information from this equation. Let's read the first statement here. Mr. Thomas cooked 45 hamburgers and hot dogs at a cookout. 45 hamburgers and hot dogs. Okay, this is not 45 hamburgers alone. No, this 45 is the number of hamburgers and hot dogs together, not only the hamburgers. So, do we know the number of hamburgers alone? No, we do not know. Do we know how many hot dogs are there? No, we don't know. So the number of hot dogs is unknown and the number of hamburgers is also unknown. But we know the total number. The total number of hamburgers and hot dogs, they together gives us 45. 45 things, hamburgers and hot dogs. We do not know the individual number. Okay, in math, what do we know? What do we do for the unknown quantities? Exactly. We assign a variable that represent this quantity. So for hamburgers as example, we can assign a variable called just x. Okay, we can just name this variable anything we want. We can say it A, B, C, or Z, anything. Okay, let's take x. Okay, what is the number of hamburgers? We do not know that number, so we can represent it by the variable x. Why? Because we do not know what is this number. Okay, the number of hot dogs is also unknown. So we need another variable here. We need to assign a variable for the hot dogs. So let's take the variable y. Y represents the number of hot dogs. It is unknown. Okay, that's why we just represent it as a variable, which is y. Okay, so we have now 45 hamburgers and hot dogs. Okay, this is the total number of them. But the individual numbers, we do not know how many hamburgers are there, and we do not know how many hot dogs are there. But we know that they together, if we just add the number of hot dogs to the number of hamburgers, how much is that will give us? It will give us 45. Okay, we can use this to we can represent this actually into an equation. So we can write the number of hamburgers, which is x, okay, if we add it to the number of hot dogs plus the number of hot dogs, which is y, okay, this will give us how much? 45. Why 45? It's just written in the question there. It is 45 together, the hamburgers and hot dogs. So here we have the first equation we need. For this system of equation, we got the first equation. It's x plus y gives you 45. And now we need to write another equation. We need to extract more information from this equation here. Let's go to the second statement and see. The second statement says, he cooked twice as many hot dogs as hamburgers. So there is a number of hot dogs that is twice the number of hamburgers. Okay? So, which means there are more hot dogs than hamburgers. Okay? The difficulty here may appear to some students in understanding this statement. Okay? He cooked twice as many hot dogs as hamburgers, which means that the number of hot dogs is equal to twice the number of hamburger. Okay? Which means also that the hot dogs is a greater number. The number of hot dogs is a greater number than the number of hamburgers. Okay, for those who has just difficulties in understanding this, we can just rewrite this statement, okay, by saying the number the number of hot dogs is twice the number of hamburgers. Okay, so the meaning of this statement, he cooked twice as many hot dogs as hamburgers, it means that the number of hot dogs is twice the number of hamburgers. Okay? Okay, I'll just keep it there in this after below it, and you need just for the first time, if you couldn't understand the first one, for the first time, just keep it in mind that it means the same thing. Now we need to interpret this situation into an equation. Okay, so we need just to try to translate this where these words into an equation. Okay, if you just have difficulties in understanding this, you can just copy this sentence here, but for now I'll just clean it. Okay, how can we just represent this in an equation? The number of hot dogs, which is y actually, is twice the number of hamburgers. Twice the number of hamburgers. The number of hamburgers is represented here, as we just suggested at the first time, is x. Twice the number of hamburgers, 2 times x. Okay, let's test it. Let's test this out. If we have 2 hamburgers, how many hot dogs are there? There are 4, which means that the number of hot dogs is greater than the number of hamburgers. So it is the same as mentioned in the statement there. So we have two equations now. We have our system of equation. Two equations here is the translation of these words into equation. Okay, and these two equations represent a system of equations. A system of equations. Okay, this is for part E, so we wrote the system of equations that is representing this situation. Now we go to part F, which is to solve this system of equations. Okay, to solve this system of equation. To do so, we just write this system at the beginning. Let's clean the things here. Okay, and prepare to move this system of equation. Okay, so the same thing that we just solved the other questions, we can start with to write the answer for this system of equations here. Can just it, yeah. So the first thing we need to do is to look at these two equations and see which equations do give us a value, an equation value for one of the variables. We can look at the second equation and see that it gives us that the value for y is how much? Y is equal to 2x. Y is equal to 2x. This is mentioned in the second equation. So we can, as we did before, take this value here, from the y here, and substitute it in the other equation, which is the second equation here, and replace the y here with the value here, 2 times x. Why? Because y is equal to 2 times x. So we take this value and substitute it to the y here. So That's basically what we do. So what we need to do now is we are substituting in the first equation. So we need to rewrite the first equation again, which is x plus y equals 45. This is the first equation. Okay. And now we need to substitute what value we know. We know that y is equal to 45. So we can rewrite the equation. And this time, instead of writing y, what should we write? We should write 2 times x because it is the value for y. So we open two parentheses, and between these parentheses, we just put the value for y, which is 2 times x. So we write 2x. It is given by the second equation. And of course, we just continue the same equation as it is. So we write equals for 45. And now we need just to simplify this equation and solve it for x and define the value for x. Here we have, actually there's no need for the parentheses here. There's nothing multiplied, but we will just do it in the second step, the following step, x plus 2 times x equals 45. And we can see here that these two terms, these two factors have the same variable. So it's like saying that you have a book and you added to that book 2 books. Okay, a book and 2 books. How much is the answer? 3 books. So it's the same as 1 plus 2, it's equal to 3 times x. This is equal to how much? It's equal to 45. What is the last step that we need to do to solve this equation here? Just divide. There's a multiplication between 3 and x. So we do the inverse mathematical process, which is to divide by how much? By that factor, which is a 3 here. And this 3 divided by 3 is 1. And not only the first side of the equation, we divide both sides of the equation by 3. So now, how much is x? X is equal to 45 divided by 3, which is equal to 15. X equals 15. Now we did it. We found the value for whom? For x. How can we find the value for y? It's easy, simple, and direct. Just take the value for x and substitute it in the second equation. You can get the value for y, right? You can substitute it here. And instead of writing x, we write 15, and then we get the value for y. You can do it mentally, or you can do it in steps for more complicated questions. So we can rewrite the second equation again. Y equals 2 times x. Okay, this equation here. And of course, if you substitute the first equation, you will get the same answer. Okay, but it is easier to substitute directly in the second equation. So you will get y equals 2 times x, but we know now the value for x. It is 15. So we open parentheses and put 15 there, and then y is equal to 30. And that's the value for y. How can we now represent the solution into a point? Okay, we open two parentheses. The x-coordinate for the intersection point between these two equations, or for the solution of these equations, or for this system of equation, is 15 for x, and the y-coordinate is 30. Okay, we can take another example by solving question 5 from the guided practice of the same page. This question here on page 246, okay, on guided practice. Let's read the question and see how can we extract the more important information and translate them into equations. I'm going just to translate these words into equations, and you need to solve the system of equations that we just solve it here, that we will get here. Okay, so 7 people went to the movies. Okay, the number of adults was one more than the number of children. Write an equation, a system of equations that represents the number of adults and children, then solve the system algebraically and interpret the solution. Okay, let's look at the first two statements. The first statement says that we have 7 people went to the movies. Okay, do we know the number of people? Yeah, we know the number of people equals to 7. Okay, the number of adults was one more than the number of children. Do we know the number of adults? No. Do we know the number of children? No, we don't know either. Okay, but we know that the number of adults is one more the number of children. Okay, how can we represent this into an equation? Again, because we do not know the number of adults, we can just give it a variable. Okay, let's give it the variable x. X represents the number of adults that went to that movie. Okay, and what about the number of children? Do we know that number? No, we don't know. So let's just give it another variable. It's an unknown quantity. So let's give it the variable y. So here we have x represents the number of adults and y represents the number of children. Okay, what do we know about these two numbers, the number of adults and the number of children? Well, it's just mentioned in the second statement of this equation that the number of adults, okay, which is x, was one more than the number of children. The number of adults equals one more, 1 plus the number of children, which is y, right? Let's just pick some numbers to make sure that this is correct. If the number of children was 5, how don't look at the equation, look at the question. The number of children is 5. How many adults are there? The number of adults will be 6. Why? Because it's mentioned in the statement that the number of adults was one more than the number of children. So does this the same if we substitute in the equation? 5 plus 1 equals 6. So we know that our answer here is correct. Okay? The number of adult is one more. And from the first semester, we know that one more means plus 1. Okay? We can just write it there or we can just write y plus 1. No, it's okay. No problem. Where you put the things because it is, you can just, it has the same priorities. Okay. Let's look at the first statement and see what's going on there and how can we represent it into an equation. 7 people went to the movies. Okay, but we know now that these people are not just people, they are adults and children. So 7 is the total number of adults and children. Like the previous equation, we can just represent this as 7 is equal to how much? 7 is equal to the number of adults and the number of children together. The number of adults is x and the number of children is what? Sorry, the number of adults is x, yeah, and the number of children is y. Exactly. So the statement here appears in the black box is the same statement as this in equation. So this equation is the translation of this statement into words. X and y equals 7. X represents the number of adults and y represents the number of children. How can we solve this equation? These systems of equation? I'll just give you the chance to try it, but we are basically looking for a value for one of the variables. We can see that from the first equation, we are given that x equals 1 plus 8, 1 plus y, sorry, 1 plus y. So we can take this value for x and then substitute it where in the other equation here. But we now know x value, not the y, like in the previous questions. we now the x value, so we need to substitute replacing the x with its value here. Okay? So we need just to rewrite the second equation, 7 equals, and instead of writing x, we write 1 plus y, then plus y again. So here we can find the y values first, then find the x value. Okay? But when we just write the final answer, we need to write that the number of adults equal to the x value and the number of children equals to the y value. Okay, I'll keep it to you just to try it at home. That's it for the eighth lesson. This was one of the most important lessons in this course, as I've said. So focus and try to do as more questions as you can. Thank you very much. See you later.